$1.7 trillion aggressively incinerated into a single aerospace project. The world calls the Lockheed Martin F-35 Lightning II the ultimate invisible ghost of the 21st century. But the dark, uncomfortable reality is that this highly classified weapon is an incredibly fragile, temperamental mechanical patient, constantly standing on the absolute brink of catastrophic physical self-destruction. We are not going to watch slick, highly edited military promotional videos today. Grab a sharp surgical scalpel, violently scrape off the multi-million-dollar radar absorbent coating, and crawl deep inside the cramped carbon composite chassis to witness exactly how extreme thermodynamic heat, violent atmospheric friction, and microscopic mechanical stress are continuously torturing the most expensive flying machine ever engineered by humanity. The matte gray skin of the F-35 is absolutely not just military paint. It is a highly toxic, deeply classified polymer chemical matrix, heavily infused with microscopic ferromagnetic particles. This fragile synthetic skin is engineered to aggressively absorb hostile electromagnetic radar waves and violently convert that incoming radio frequency energy directly into raw thermal heat. But its ultimate mechanical Achilles heel is pure aerodynamic friction. As the heavy titanium airframe violently breaks the sound barrier and accelerates dangerously past Mach 1.6, the brutal atmospheric friction aggressively bakes the aft fuselage section. The multi-million-dollar radar absorbent material physically cannot withstand this sustained thermal torture in the high-altitude environment. It begins to physically blister, violently bubble, and aggressively peel off the composite airframe in jagged, burning chunks. The stealth geometric architecture demands absolute, punishing physical perfection from the maintenance crews. The exterior surface of this flying supercomputer cannot tolerate a single mechanical wrinkle or structural deviation. If a single heavy-duty titanium screw protrudes even 1 microscopic millimeter above the smooth carbon fiber wing surface, or if a microscopic scratch from airborne desert sand mars the fragile polymer skin, it immediately generates a massive radar cross-section spike. That single microscopic mechanical flaw, totally invisible to the naked human eye, is geometrically large enough for a hostile S-400 surface-to-air missile radar array to instantly achieve a hard lock. In a fraction of a second, that 1 millimeter manufacturing defect invites a hypersonic interceptor missile to detonate directly in the pilot's face. To maintain this impossible standard of physical perfection, ground crews are forced to operate exactly like highly stressed aerospace surgeons. Every single access panel, every fuel port, and every weapons bay door is painstakingly sealed with specialized radar-absorbing putty. This thick, toxic chemical paste must be perfectly smoothed out by hand to absolutely eliminate any microscopic aerodynamic gaps. When the aircraft returns from a grueling supersonic sortie, the intense atmospheric pressure and violent structural flexing of the titanium wing spars have inevitably cracked this fragile putty. The maintenance teams must aggressively scrape out the ruined chemical seals, completely reapply the toxic paste, and wait hours for it to cure before the machine is allowed to fly again. This is not a robust mechanical weapon designed for the dirty, chaotic reality of a prolonged global war. It is an incredibly delicate, high-maintenance sports car forced to operate in a supersonic meat grinder. The sheer aerodynamic stress of pulling a violent 9G combat maneuver physically bends the heavy metal airframe, threatening to snap the microscopic chemical bonds of the radar-absorbent skin and instantly strip away the pilot's only defense against incoming radar-guided annihilation. Beneath this blistering, peeling layer of toxic synthetic skin lies the complex skeletal structure. The internal ribcage is forged from highly advanced bismuth imide carbon nanotube composites and heavy titanium bulkheads. These materials were specifically chosen to aggressively shave off every possible ounce of physical weight while surviving the crushing gravitational forces of aerial combat. However, mating rigid titanium components directly to flexible carbon fiber composites creates a terrifying mechanical nightmare. As the aircraft rapidly changes altitude, plunging from the freezing negative 50-degree temperatures of the stratosphere down to the blistering heat of a desert runway, the different materials aggressively expand and contract at completely different physical rates. This relentless thermodynamic cycling generates massive internal shear stress along the thousands of microscopic aerospace fasteners holding the fragile airframe together. Every single flight hour slowly microfractures the internal composite structure, secretly weakening the $100 million machine from the inside out. Deep within this slowly microfracturing carbon shell sits the absolute mechanical heart of the crisis: the Pratt & Whitney F-135 turbofan engine. This is undeniably the most powerful fighter engine ever constructed by human hands, generating a catastrophic 43,000 pounds of raw, earth-shattering thrust. To achieve this apocalyptic power, the high-pressure titanium turbine blades violently spin at tens of thousands of revolutions per minute, aggressively compressing atmospheric air and forcing it into a combustion chamber that operates at a terrifying 2,000 degrees Celsius. This is a thermal environment hot enough to physically melt the engine's own internal superalloys. To prevent the turbines from instantly turning into liquid metal slag, microscopic cooling holes are laser drilled directly into the spinning blades, constantly bleeding a fragile microscopic film of cool air over the heavy metal. But this astronomical generation of thermal energy creates an absolute physical nightmare for the stealth geometric architecture. A conventional fourth-generation fighter jet simply uses massive open-air intake vents to dump excess engine heat directly into the atmosphere. The F-35 absolutely cannot do this. A large cooling vent is a massive, gaping structural hole to enemy radar waves. Therefore, this flying supercomputer is forced to physically trap its own apocalyptic thermal radiation deep inside the tightly sealed composite airframe. The advanced avionics, the active electronically scanned array radar, and the massive electronic warfare jamming suites all generate immense amounts of parasitic heat. Without adequate atmospheric ventilation, the F-35 literally begins to slowly bake its own highly classified silicon nervous system alive. To solve this catastrophic thermal bottleneck, aerospace engineers were forced to implement a brilliantly terrifying mechanical workaround. They physically weaponized the aircraft's own highly volatile jet fuel as a primary liquid coolant system. Before the freezing cold aviation fuel is aggressively injected into the 2,000-degree combustion chamber, it is violently pumped through a complex, microscopic maze of heavily armored heat exchangers wrapped tightly around the glowing hot avionics and engine casing. The cold jet fuel physically absorbs the immense parasitic heat, acting as a massive thermal sponge to keep the fragile silicon brain from completely melting down mid-flight. This is an incredibly brilliant, yet fundamentally terrifying mechanical compromise. The aircraft is literally using thousands of gallons of highly explosive volatile liquid as a giant flying radiator. If a single microscopic pressure valve violently jams, or if a high-speed fuel pump experiences a catastrophic mechanical failure during a prolonged supersonic dogfight, the internal thermal management system will instantly collapse. The stagnant jet fuel trapped inside the heat exchangers will rapidly boil, violently expanding and aggressively tearing the fragile internal plumbing apart from the inside. In a fraction of a millisecond, the absolute pinnacle of human aerospace engineering is instantly transformed into a $100 million supersonic thermobaric bomb, completely erasing itself and the pilot in a blinding flash of catastrophic overpressure. Deep within the forward fuselage, the F-35A conceals its most violently destructive kinetic weapon behind a fragile, meticulously sealed stealth door. The General Dynamics GAU-22 A25mm rotary cannon. When the pilot aggressively pulls the trigger to engage a close-range target, a massive internal electric motor violently spins the 4 heavy steel barrels, unleashing a catastrophic 3,300 high-explosive incendiary rounds per minute. However, because this heavy weapon is physically trapped deep inside the delicate stealth geometry to prevent radar detection, the massive acoustic shockwave and brutal mechanical recoil have absolutely nowhere to escape. The deafening, concussive muzzle blast violently ricochets back inside the cramped, tightly packed composite airframe. This apocalyptic vibration actively generates microscopic physical fractures along the heavy titanium bulkheads holding the weapon assembly in place. The extreme kinetic violence and raw mechanical friction physically tear the delicate, multi-million-dollar radar absorbent coating completely off the exterior muzzle door. In the exact millisecond the aircraft chooses to physically fight back, it aggressively strips itself of its invisible stealth cloak, instantly lighting up on enemy radar screens like a massive burning beacon. But the absolute peak of this terrifying mechanical self-destruction occurs directly on the belly of the beast. To strictly maintain a perfect zero radar cross-section, the F-35 is forced to carry its heavy 2,000-pound joint direct attack munitions, completely locked inside 2 cramped, suffocating internal weapons bays. When the highly classified digital kill chain is finally executed, heavy hydraulic actuators must violently snap the heavy composite bay doors open in a fraction of a single second. Opening these doors at a blistering supersonic velocity of Mach 1.2 exposes a massive hollow cavity directly to the roaring atmosphere, creating a catastrophic physical phenomenon strictly known as supersonic cavity resonance. The incoming supersonic airflow violently slams into the rear titanium bulkhead of the empty weapons bay, generating a massive, pulsating acoustic shockwave exceeding 160 decibels. This apocalyptic vibration acts like a massive invisible mechanical hammer, physically bouncing around the internal bay. It is powerful enough to aggressively rip the heavy composite doors completely off their titanium hinges, sever fragile hydraulic lines, or instantly shatter the delicate optical glass of the internal targeting sensors. To strategically prevent the aircraft from literally vibrating itself into a million burning pieces, engineers had to surgically implant active aerodynamic spoilers that violently deploy into the slipstream to forcefully disrupt the supersonic airflow just milliseconds before the heavy payload drops. The F-35 Lightning II is absolutely not a perfect, invincible flying machine. It is a terrifying, highly compromised mechanical paradox, violently forcing the uncompromising laws of aerodynamics and thermodynamics to bow to the illogical geometric demands of absolute stealth. Every single minute spent screaming through the stratosphere is a desperate physical battle for survival between the cold, calculated precision of its silicon brain and the aggressive, tearing destruction of atmospheric friction and trapped, agonizing heat. This smoking, micro-fracturing stealth fighter forces us to aggressively question a dark, uncomfortable reality. Has our absolute obsession with radar invisibility transformed modern combat aircraft into incredibly fragile mechanical patients, requiring the most extreme, expensive surgical care on the planet. Do not forget to subscribe to the channel and leave a comment below if you want us to aggressively dissect the catastrophic explosive sequencing and brutal spinal compression of modern 00 fighter ejection seats in our next video.